Good morning, my lovely kiddos and my future mathematicians. Today we are going to be talking about 9.5b, and we are going to be solving with our tangent ratios. Our trig ratios. Tangent is one of our trig ratios, but we are solving with all of our trig ratios. That is sine, abbreviated SIN, cosine, abbreviated COS, and tangent, abbreviated TAN. Okay, so we had a saying yesterday to help us remember each of our trig ratios, and that phrase was so ka toa. Okay, and this stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're going to use this phrase that we must write on all tests and all assignments to solve for some sides here. So for our first example here today, we have a right triangle, which is awesome because we need a right triangle in order to do any trig ratios. We have the side lengths of 14, x, and y, and then we are given one angle, and that is 26 degrees. So, looking at our 26 degrees, we are going to determine which side is the opposite side, which is our adjacent side, and what is our hypotenuse. So from our 26 degrees, the opposite side, the side furthest from, the side not touching this 26 degrees is going to be this x here. So we are going to label it with an O for opposite. Now the leg adjacent to 26 is going to be the leg that is touching 26, the leg that is right next to 26, that is not our hypotenuse. This is going to be the y. We know that y is a leg because it's also touching our 90 degrees. So this is our adjacent side, so I'm going to label it with a capital A. And then finally, our hypotenuse is going to be the side across from our 90-degree angle, the side opposite from our 90-degree angle. So I'm going to label that with an H. Now, I would first like to solve for x. So x is my opposite side. I need a ratio with an O in it in order to solve for my opposite side. So I cannot use this middle piece, our ka piece, or our cosine. Okay, so we either have to use our tangent or our sine function. We want to use the side that has been given to us, and this is our hypotenuse. So since we are trying to find O and we have H, we have to use our sine function here. So we're going to solve these in 3 steps. First, we're going to set up. So all of our setups are going to look pretty similar. We're going to write our trig function, in this case sine, of some angle is equal to, and then we write our ratio, opposite over hypotenuse. All right, in our setup step, I don't want any of our information yet. That comes in step 2, our substitute step, where we plug in everything we know. So we're still using our sine function. Our angle is 26 degrees. And then our opposite side, our O, is x. And then our hypotenuse, our h, is 14. We're going to put the sine of 26 over an invisible 1 here so that they are both fractions and we can cross multiply. So x times 1 just gives us x. And the sine of 26 times 14 is where we bring in our calculator. So we're going to hit our sine function, plug in our angle, which in this case is 26, and close our parentheses, and then multiply by that 14. So this gives us 6.137. I only want 3 digits after the decimal point. So our answer here is 6.137. So we solve for x. Now I would like to solve for y. So y is our adjacent side. So we need to find a ratio, a trig ratio that has an a in it, meaning we cannot use sine again. Okay, and again, we look at the side that has been given to us, our hypotenuse. So we want a function with a and h in it, which is going to be this ca piece, our cosine. So again, solving in 3 steps. First, we have to just set up, and our setup steps are going to look very similar. We have our trig function of some angle is equal to its ratio. Cosine is adjacent side over hypotenuse. Step 2 is our plug-in step, so we plug in what we know. We still have our trig function. Our angle is 26 degrees. Our adjacent side is our unknown, or our y, and our hypotenuse is still 14. We're going to put our cosine over an invisible 1 here, and then cross multiply. So y times 1 gives us y, and cosine of 26 times 14 is where we bring in our calculator. So again, plugging this in, cosine of 26, close our parentheses, times 14 gives us 12.583. Again, just wanting 3 decimals after 3 places after the decimal. So 12.583. All right, let's go ahead and do one more here. For our second problem, again, we have a right triangle, which is awesome because that's what we need to in order to do our trig functions here. I'm going to go ahead and write SOHCAHTOA one more time down here so we can see it in the view of the camera as we do this problem. Okay, here we have the side lengths of 10, B, and A, and then the angle of 48 degrees. So again, the first thing we want to do is determine which side is our opposite, adjacent, and hypotenuse. So from this 48 degrees, the side that is furthest from the side that is not touching the side that is across from this 48, our B, is our opposite side. So I'm going to label this with an O. The adjacent leg, the leg that is touching our angle here, is going to be our adjacent side. Remember, we know it's a leg when it is also touching our 90-degree angle. So I'm going to label this 10 with a capital A. And finally, we want to identify our hypotenuse, which is always opposite from our 90-degree angle. It's our largest side. So I'm going to label this side with a capital H. I would like to solve for A first. So that is our hypotenuse. So we know that we have to pick a trig function with an h in it. Okay, and we know our adjacent side. So we know we have to pick a side with an a in it as well. So we need something with a and something with h. So that's going to be our cosine again. Using our 3 steps, step 1 is set up. We have our trig function, cosine, and then of some angle is equal to its ratio, which is adjacent over hypotenuse. Step 2, we plug in what we know. Cosine of 48 degrees is equal to our adjacent side of 10 times our hypotenuse of A. We're going to put an invisible 1 under the cosine of 48 so that we can cross multiply. Cosine of 48 times A gives us A times the cosine of 48. And 10 times 1 gives us 10. Now we want to get A by itself, so in order to undo this multiplication, we will have to divide out by its giant coefficient of the cosine of 48. Ooh, I didn't mean to put parentheses there. That's okay, we'll just have double parentheses. Multiply by the cosine of 48, divide by the cosine of 48. Those are going to cancel because they go to 1, leaving us with just a positive 1a. And then 10 divided by the cosine of 8 is where we bring in our calculator once again. So we have 10 divided by the cosine of 48, close parentheses. And we get 14.944. All right. So all we have left to do is solve for B. All right, I'm going to do that over here. We're going to solve for B. B is our opposite side. So we need something with an O in it. And we are given our adjacent side. So we want a function that has both O and A in it, which is our TOA piece or our tangent. So we're going to go ahead and do our setup, substitute, and solve. So we have our trig function of some angle is equal to its ratio. Tangent is opposite over adjacent. Step 2, we plug in what we know. We still have the tangent, and our angle is 48 degrees. Our opposite side is our unknown, or our B, and our adjacent side is, again, 10. Putting our tangent of 48 over an invisible 1 so that we can cross multiply. B times 1 gives us B, and the tangent of 48 times 10 is where we bring in our calculator for the last time. So we have the tangent of 48, close our parentheses, times 10 gives us 11.106. 11.106. All right. So now using our trig functions, we have solved for 2 missing side lengths, and I think that is pretty cool.